Okay, welcome back to C# application development. Today we're going to talk about a little bit more syntax basics, and we're going to really build off of last time. So in the last video, we talked about extremely rudimentary sort of stuff like variables, very simple control structures. We kind of implicitly covered operators and that kind of thing. And so this time what we want to talk about is the next, what I'm going to refer to as baby step in this whole process, and that is methods and classes or partial classes, which will give you the first kind of insight into how C# is different in some ways than Java. So object orientation in C# is really inextricably linked to the language's syntax just in general. We can't really draw a good line between what an object-oriented program in C# is from just standard language syntax. There is no such thing as procedural C#. So next week, what we're going to do is we're going to focus on object orientation in its sort of proper sense with interfaces and inheritance and all that kind of stuff. But for now, what we're going to talk about is what I am rudimentarily or sort of very roughly calling encapsulation. So methods are going to seem very, very similar to you if you've ever seen Java or C++, if you've ever been in an object-oriented programming class before. Methods basically just encapsulate business logic, and they cut up the different things that a class is capable of doing so that you don't have one just sort of monolithic piece of procedural code that you need to troubleshoot or maintain in some way. So there are two really basic flavors of methods. There are static methods, there are non-static methods, and just like with C++ or Java, a static method is not associated with any single instance of a class. It's basically at the type level or the class level. A non-static method is associated with an instance of a class. And so not to insult anyone's intelligence, but as kind of a reminder, the difference between a class and an object is that a class is a blueprint for what data and what behavior an object, which is an instance of that class, should have. So for example, you could have a class that is a car class. Your specific car that is a Ford Taurus or whatever would be an instance of that class or an object. And so you could have methods that exist at the class level that are the same sort of behavior for every different object. Those would be static, but you could also have specific kind of methods that are behavior for your specific car. So you would not necessarily want a static drive method because you wouldn't want your car to be driven when all other cars are being driven, so on and so forth. So in C#, the static methods or static properties are invoked from the class or type name. Non-static methods are invoked from a specific instance, so an object or a variable that is of the type of that class. Static methods represent behavior that is type specific. Non-static methods represent behavior that is specific to the object or the instance of that class or the variable of type class that you're using in your program. So exactly like a method can be static or non-static, fields and properties can also be static or non-static. What we want to highlight here is that in general, a public static property is not a great situation. So what it means to be public and static is that your property is exposing global state. Global state in general is not a good idea because many different applications could be accessing that state. They could be accessing that state at different times, and if that state gets updated, it's kind of your job to make sure that anything that accessed that state in the past is updated correctly going forward. So if you think about computer organization, you could have caches that are out of date. That's very much what global state can lead you to if you're not careful. So if you have global state exposed on a class, that class gets read by 100 other classes, and then suddenly that global state is updated. You have to have a mechanism to broadcast that update to all those 100 other classes that just read your state. There are patterns to do this. It's certainly a thing that's possible, but typically it's not a great idea. It's certainly not a best practice. And trying to perform that synchronization over many classes through time is not a trivial thing to work all the bugs out of. So just a sort of general programming guideline, in C#, exactly like in Java or any other language, ideally you want to have a method that does a single thing. So you don't want to lump a bunch of behavior into the same method. And the reason is because the more complicated, the more lengthy a method is, the more likely that method is to be buggy. So what you want is you want to be able to take a method that's very large and segment that into as many smaller methods as possible, if only for unit testing purposes, or to make the code more reliable by basically being able to guarantee in some ways that your smaller methods actually do the thing that they're trying to do. So there are lots of language features around methods for modern languages, and C# supports almost all of those that you could think of, including some that are not necessarily a great idea in general. So the first of those that we're going to talk about is method overloads. So exactly like Java and C++, C# supports the same method having a different signature with the same name. And largely, that is a helpful thing when changing method signatures in production code. So if you think about getting a job in a .NET shop, you're not necessarily building a method from the ground up. You're potentially inheriting a method that already has a set parameter list, that already has a return type, it already has a signature that you don't necessarily want to change. You don't want to change it because changing the signature of a production method is extremely frightening, because you could potentially break a bunch of code that you don't actually know exists. So one of the best things or reasons you might use a method overload is to help skirt this issue by creating a brand new method that has a different signature than the existing method, and then using the new method to default parameters into the old method. And so this is often called a method hook or method override hook, and this is something that we will talk about specifically in the code along. So another very related method feature is default parameters, where you can supply default parameters that make your parameters in the method signature optional. This is the same feature functionality used in both Java and C++. Typically, people believe that this is not a best practice, and the best practice is actually to use an overload, because the overload makes it much more clear to the person calling the method what the method is actually going to do, and it opens you up to less technical debt going forward, because there's no real interpretation that has to happen when somebody comes in to review the code to make changes. The potentially more strange and bizarre language feature is called named parameters. What this allows you to do is take a parameter list for an existing method signature and jumble the order in which you pass the arguments. So let's say that you had 3 arguments, A, B, and C. If you wanted to provide A, B, and C out of order, you could specify the name C for the first argument, and even though it's passed as the first argument, it would not go into the A parameter, it would go into the C parameter. Likewise, you could specify A and B for the second and third parameter, and now you have called the method in the exact same way that you would have, just with a different ordering of arguments. and you have named those arguments with the parameter names that are expected by the method. This is certainly an interesting language feature. It's obviously a pretty bad idea for production code unless you're using it for a very, very, very specific reason that I can't actually even fathom right now to provide an example. So in general, if you find yourself using either default or named parameters with any sort of frequency, it's usually a major sign that the system that you're working on has some profound technical debt. You have added a whole bunch of parameters instead of splitting up the method. You have done, or maybe not you, maybe the organization has done something in days of yore that has caused some pretty significant issues that you need to work through. One of the more interesting kind of encapsulation features that C# supports are called partial classes. I am not aware that Java has an equivalent to partial classes. I could totally be wrong, but basically you can think about it like this. C# certainly allows you to have multiple classes to be declared in the same .cs file. And so while it's a good idea to have multiple CS files, one for every class, you could actually just pile all of the code for your entire 2 million line application into the same file, and you could live your life that way. It's just not a very great idea because it makes it kind of hard to navigate around. The converse is also true. So C# also allows you to take a single class, so a single kind of technical entity, and split that across multiple files using the partial keyword. So what this does is it lets you take perhaps a data class. So think about like a bank account class or something like that. And you can have some of it on the client side, and you can have some of it on the server side of an application, and the files are physically separated. The file that has the server side components of the account class never even touch the client's machine at all. They stay exclusively server side. This is going to become a little bit more apparent. It's going to become more useful as we go through the course and talk about multi-tiered application development. But just know that this is a thing that C# allows you to do. Not only can you have multiple classes in a single file, you can actually have the same class across multiple files, which is kind of a weird situation. And it's important to note that even though you can use partial classes to span multiple source code files, those files should reside in the same assembly, and they should reside in the same namespace. So what you cannot do is span an assembly with a partial class, because the compiler will not understand where the code is to generate the rest of the runtime code to actually be run in the virtual environment. So while you can span multiple physical files, you kind of have to put them in the same assembly, in the same namespace, so that the compiler can link and keep everything together. So one of the things that we're going to talk about going through the course is the idea that classes in the sort of traditional object-oriented design pattern can have both state and behavior. However, we're going to look at ways to completely separate the state and the behavior of what larger kind of ephemeral concepts we'll begin calling entities. So when I say entity, what I really mean is like a generalization of a class that actually represents a business concept. So we were talking previously about a bank account, for example. Bank account could certainly be a class, but there could also be maybe services that implement the behavior of that idea of what a bank account can actually do. There could also be persistence components that actually save a bank account's current state to some deep storage somewhere, a database or a file system. So while historically we've talked about classes and how they contain both data and state, we're going to kind of walk down a path where classes can have different ideas around them. And so we're going to call those classes that store state data classes. These are going to ultimately grow up to be entities that are persisted through entity framework. And we also have controllers that are going to manage the behavior of those entities. And so one of the things that we're going to focus on pretty heavily near the middle toward the end of the class is building REST API web services. And one of the central sort of ideas of REST is that the classes that implement those web services be stateless. And one of the ways that you can do that is by offloading all of the state from those controller classes to these entity classes that are then used for persistence at both the sort of database or deep storage level, as well as in RAM actually performing business functions through other supporting classes. So this is one thing I wanted to bring up that will not become abundantly clear during the object-oriented discussions, but will become clear as we sort of march down the path toward RESTful services. So one note about the code along. So the next video is going to basically just be me and Visual Studio creating a 5-function calculator. So what we're going to do first is do all of that coding without these encapsulation ideas, basically just using control structures. Then we're going to break all of the pieces out into their own encapsulated pieces to kind of give you a feel for basically how C# kind of works. It is going to not be anything earth-shattering, but it will be a very, very good primer for what the first programming assignment in the course will be about. And so the requirements of that assignment will be found at the end of this module. It's effectively just a very simple point of sale system that is going to add some slight bells and whistles to a 5-function calculator. So if you are already familiar with Java, the programming assignment 1 in the course is going to probably make you laugh a whole lot, and that's totally fine. As I talked about earlier, the unfortunate thing about the course is that the programming assignments kind of increase exponentially in difficulty. So if you find this one to be extremely beneath you, wait, give it about a week, maybe 2 weeks, we'll be into something much, much more technologically engaging. So thank you very much for listening, and I hope that you enjoy the code along, and we will get deeper and deeper into this kind of thing, and the programming assignments and all of the technology around them will become much more interesting than just this kind of basic syntax stuff. Thanks again, and see you next time.